Welcome back guys, my name is Jadip Chakraborty. Today in this video, we'll be discussing about Supernode analysis. Throughout this video, we'll discuss about what is Supernode and we'll understand that with some examples. Also in this video, we'll be solving some numerical problems. So without wasting any time, let's start. Before we dive into this video, let's try to answer a question. Why Supernode? Why do we need to learn Supernode? To answer this question, you just look at this question and take some time and just think whether or not can you solve this question with the basics of nodal analysis. So actually the answer is no. With the basics of nodal analysis, we can't solve this question. Why? It's because KCL plays a very important role in nodal analysis, and to apply KCL, we need to know the branch currents. Let us try to find out the branch currents in this question. So for this, if we take this node, for this, if we write nodal equations, it's 2, that is equals to V1 minus 0 divided by 2, that is V1 minus 0 divided by 2, and that is, now it's what? Now what will you write in this? Do you know this branch current? Do you know the branch current that is flowing in this branch? No. It is actually impossible to know this branch current value well in advance. So in this type of question cannot be solved with the basics of nodal analysis. That's why we need supernode analysis. So let's move to the next slide. Now, what is a supernode? A supernode is formed when in between two non-reference nodes there is a voltage source present. Now that voltage source can be dependent or independent. Okay, so let's take this circuit for example. In this circuit, this is your non-reference node, this is your non-reference node, and this entire is your reference node, right? So that's your reference node, and these two are your non-reference node, and in between these two non-reference nodes we can see there is a voltage source, that is basically a independent voltage source is present in between these two non-reference nodes. So that is why we can name this entire node to be as supernode. Now let's look in this circuit. This is your reference node, this is your non-reference node, and this is your non-reference node. So here we can see in between these two non-reference nodes there is a dependent voltage source present. Dependent voltage source. So now this becomes your supernode, because in between these two non-reference nodes there is a dependent voltage source present, and this dependent voltage source is basically a voltage controlled voltage source, VCVS, voltage control voltage source, because the magnitude of this voltage source depends on the magnitude of this voltage, that is this Vx. So let's move to the next slide. Now let's solve this actual question. Let's say this is your question. What the question says, the circuit is given and find out the node voltage. So let's try to solve this. What are the node voltages? This is V1 and this V2. V1, V2 we have to find out. So what we need to do is V1 is how much and V2 is how much. This is what we need to find out. Now how will you solve that? First, let's follow the steps of nodal analysis. This is basically the steps of nodal analysis that we have discussed in the previous video. And if you haven't watched the previous video, so I will recommend you to watch the previous video and then see this video. You can find that video in the I button. So let's identify all the nodes. That is your node, that is your node, and this is your node. So this is your reference node, and these two are your non-reference node. Okay, now it says set a reference node and assign V is equals to 0. Since we have set this as a reference node, so we'll assume this node voltage to be as 0, and this non-reference node, so we'll assume this node voltages. So this node voltages is given, that is V1 for this node and V2 for this node. Now before we move to the second step, we can see that this is a problem of supernode. Why? Because in between these two non-reference node, this independent voltage source is present over here. So this is your supernode, right? Now step 2, write down the nodal equation for n-1 nodes. What is n-1? Over here n is equals to 3, 1 2 3, right? Out of that, so how many number of nodal equation we will have? n-1. That is over here, it's 3 minus 1 is equals to 2 nodal equations. Okay, out of these two nodal equation, one equation we will get by applying KVL at supernode, and another we will get by applying KCL at supernode. V1 minus V2 is equals to 2 volt. That's your equation. V1 minus V2 is equals to 2 volts. That's your equation number 1. And this equation we got by applying KVL at supernode. Right. Now, what about the other equation? Now, to write the other equation, we will be using the KCL. For writing the another equation, we will assume that these two nodes are a single node. So 2, that is 2 ampere coming. So that is equals to V1 minus 0 divided by 2, that is V1 minus 0 divided by 2, plus V2 minus 0 divided by 2 plus 2 amps. So what it becomes? V1 plus V2 is equals to 0. That's your equation number 2. Now solve equation number 1 and equation number 2. And so V1 is your 1 volt. Now applying this in the equation 1, we will get V2 is equals to how much? Minus 1 volts. So that is your answer.